Hi, I am CVR. Now I will discuss the horizontal projection from the top of a tower. So here this is a tower. This is a tower of height is h. Now if a body is projected with a velocity is u, that is projected along horizontal direction, means there is no velocity in the vertical direction. So initially that velocity is projected with a velocity is u along horizontal direction. Now our aim is, what is the velocity of this body after some time t somewhere here, wherever, and what is the time taken by the body to reach the ground, and what is the horizontal distance travelled by this body, and what is the velocity of this body at this landing position. So first our aim is to calculate the velocity of this body after some time t. For that, first you write what is the initial velocity along x direction. So here initial velocity along x direction is u, and initial velocity along y direction is 0, because the entire velocity is along horizontal direction. So there is no velocity in vertical direction. And similarly, the acceleration along x direction and acceleration along y direction. So here the acceleration of the body is acceleration due to gravity. Acceleration due to gravity is acting vertically downward direction. So there is no acceleration along horizontal direction. Entire acceleration is acceleration due to gravity, that is acting vertical direction. So there is no acceleration along horizontal direction. So here first our aim is to calculate velocity of the body after some time t. For that, what is the velocity along x direction and what is the velocity along y direction? Velocity along x direction. So here initial velocity along x direction is u and acceleration along x direction is 0. The velocity of the body along x direction after some time t is Vx is equal to ux plus ax into t. That is ux is u value, ux is u plus ax is 0 into t, that is u. So here velocity along horizontal direction after some time t is u. This is the independent of the time. Now what is the velocity of the body along vertical direction? Vy is equal to uy plus ay into t. So here initial velocity along vertical direction is 0 plus ay is minus g. So minus g into t. So Vy is equal to minus g into t, where this minus sign indicates that after some time t, the velocity of the body is in the vertically downward direction. After some time t, the velocity of the body, this is the velocity along x direction and this is the velocity of the body along y direction. So here minus sign indicates that velocity after some time t along vertical direction is in the downward direction. Now what is the total velocity of the body? So we add, this is the total velocity. This is the total velocity of the body. You add, so here this is a vector quantity, we add v bar is equal to vx into I cap plus vy into j cap. So magnitude, this v bar is u into I cap plus minus gt into j cap. This is the v bar. V bar is equal to ui cap minus gt into j cap. The magnitude of this velocity v bar is, what is the magnitude? Under root I cap quotient whole square plus j cap quotient, that is minus gt whole square, that is nothing but g square t square. This is the magnitude of the velocity after some time t. And what is the direction of this velocity? And what is the meaning of the direction? how much this resultant velocity makes an angle with this horizontal direction, that is the direction. So here the direction is tan alpha is equal to Vy by Vx. Tan alpha is equal to magnitude of Vy divided by magnitude of Vx, that is gt divided by u. This is the velocity of the body after some time t. Next, displacement of the body after some time t. Displacement of the body after some time t. So here, what is the displacement along horizontal direction? Sx is equal to ux into t plus half ax into t square. So here ux is u into t. Sx is nothing but x. That is x represents the displacement along x direction. And similarly, what is the displacement along vertical direction? Sy is equal to uy into t plus half ay into t square. Sy is nothing but y, uy is 0, 0 into t minus half gt square. So here y is equal to minus half gt square, where here this value of y minus sign indicates that after some time t the body is below the projection point. After some time t the body is below the projection point. Suppose here body is somewhere here, this is nothing but x and this is nothing but y. So x value ut, y value minus half gt square in minus sign represents that body after some time t is below this projection point, that is the minus sign indicates. Next, time for flight. Time of flight. The time taken by the body here, this time taken by this entire body to reach the ground, that is nothing but time of flight. So how to calculate time of flight? So here we know that y is equal to minus half gt square. We know that y is equal to minus half gt square when the body is at landing point. When the body is at landing point, the value of y is h. When the body is at landing point, the vertical displacement of the body is h value. So that is the below the projection point. So y is taken as minus h. So that is minus h is equal to minus half gt square. Minus minus cancel. So here t is equal to under root 2h by g. This is the time taken by the body to reach the ground, that is time of flight. T is equal to under root 2h by g. Next, range of this body, range. Now calculate range. What is the meaning of the range? Range is nothing but the displacement of the body along horizontal direction. Displacement of the body along horizontal direction is nothing but the range. So for that range, we know that x value is ut. We know that x is equal to ut. Here, if you substitute this t is root of 2h by g, then that x is called range, because the total time taken by the body to reach the ground is root of 2h by g. So in that case, that x is called range. So r is equal to u into t is under root 2h by g. This is the range of this horizontal projection. This is the very important formula. Next, velocity of the body at landing point. Next, velocity of the body at a landing point. How to calculate the velocity of the body at landing point? So here, at this point, this body have horizontal component of the velocity, that is Vx, and the vertical component of the velocity, that is Vy. So here, the horizontal component of the velocity, each and everywhere, the horizontal component of the velocity remains same. Each and everywhere. Even at this landing point also, that horizontal component of the velocity remains fixed. That is u. So at landing point, the horizontal component of the velocity Vx is equal to u. And similarly, the vertical component of the velocity, what is the Vy? Vy is equal to uy plus ay into t. So here uy is 0, because uy is 0, and ay is minus g into t is the total time. So here you want to calculate the velocity at this landing point. So in this case, the time t is time of flight, that is root of 2h by g. So root of 2h by g. This can be written as minus root 2gh. Where here the minus sign indicates that the velocity after some time t, or the velocity at landing point, is in the downward direction. So here this velocity is in the downward direction. So that is the total velocity. This is Vx and this is the Vy. What is the total velocity? V bar is equal to Vx I cap plus Vy j cap. So substitute this Vx value and Vy value, then you will get the total velocity V bar is equal to Vx I cap plus Vy j cap, that is Ui cap plus minus root 2gh into j cap. Now what is the magnitude of this velocity? V is equal to under root u whole square plus minus root 2gh whole square. So V is equal to root of u square plus 2gh. This is the total velocity of the body at landing point. Next, equation of trajectory. What is the equation of trajectory? What is the meaning of the equation of trajectory? What is the name of this path? What is the name of this path? This path. So that is called the equation of trajectory. That path, if you express that path in terms of x and y, that is called equation of trajectory. So for that equation of trajectory, we know that x is equal to u into t and y is equal to minus of gt square. So from this, t can be written as t is equal to x by u. Substitute this t value in this equation. Y is equal to minus 1 by 2 into g into x by u whole square. So y is equal to minus g by 2u square into x square. Y is equal to minus g by 2u square into x square. This you consider this minus g by 2 square is nothing but k, where k is equal to minus g by 2u square. So this equation represents y is equal to kx square equation represents parabolic equation. So our projectile motion, our horizontal position from the top of a tower, our projectile motion is a parabolic path. This is about the horizontal position from the top of